Here is a question your AI cannot answer. You feed it 1,000 company documents and you ask, what are the main themes across all of this? And it falls flat. Not because the answer isn't in there, it's because of how it searches. Normal RAG reads every document, but it can only ever grab a few isolated paragraphs at a time, the ones that look similar to your question. So it can quote you a single line beautifully, but it cannot connect two facts that live on different pages. It reads everything and connects nothing. Today, a fix from Microsoft Research changes that completely. It's called GraphRAG, and instead of searching your text, it maps it. Once you see how it works, you'll understand why this is the next era of retrieval. Let me show you. First, let's be fair to normal RAG because it is genuinely useful. Here's how it works. You take your documents and you chop them into chunks. You turn each chunk into a vector, a list of numbers that captures its meaning, and you store all of them. Then, when you ask a question, your question becomes a vector too, and the system grabs the top handful of chunks that sit closest to it. That's it. Find the most similar paragraphs, stuff them into the prompt, answer. And for a narrow factual question like, what is the refund window in this contract? It works great. The answer lives in one chunk and similarity search walks right up to it. But notice the quiet assumption baked into this whole design. It assumes every answer lives inside one nearby chunk, and that assumption is exactly where it breaks. Here are the three questions that shatter normal RAG. Number 1. Connecting the dots. When the answer requires stitching together facts scattered across many different documents, similarity search can't do it because no single chunk contains the whole picture. Microsoft's own words. Baseline RAG struggles to connect the dots. Number 2. Multi-hop reasoning. Who funded the company that acquired the startup this researcher founded? To answer that, you have to hop across a chain of links, and the bridge facts in the middle don't even look similar to your question. So the search never retrieves them. And number 3, the big one, global questions. What are the main themes? What changed over time? Who are the key players? These are summarization over the entire corpus, not a lookup. And top K similarity only ever sees a tiny slice. So it literally cannot answer a question about the whole. These aren't edge cases. This is most of the interesting questions you'd ever want to ask. So GraphRAG asks a completely different question. What if we stop searching the text and start mapping the knowledge inside it? Watch what happens. Instead of leaving your documents as a pile of paragraphs, GraphRAG reads them and pulls out the things, the entities, people, companies, products, places, concepts. And then, crucially, it pulls out the relationships between them. This person founded that company. That company acquired this product. Connect enough of those, and your flat pile of text becomes a web, a knowledge graph. Now, the connections between facts aren't lost in the gaps between chunks. They are the data. And the moment your knowledge is a graph instead of a bag of paragraphs, every question that used to be impossible becomes a walk across the map. So, how does it actually build that map? This is the indexing pipeline. And the clever move is that it uses the language model itself as the builder. Step 1, it still chunks your documents into pieces. But step 2 is where it diverges. For every chunk, the LLM reads it and extracts a structured list. Here are the entities in this text with a short description of each. And here are the relationships between them. Then it does that across every chunk and stitches the results together. When the same entity shows up in 10 different documents, those 10 mentions get merged into one node, and all its descriptions get summarized into one. By the end, you don't have 1,000 disconnected chunks. You have one connected graph of who and what and exactly how they all relate. But a giant graph on its own is just a hairball. The real magic is the next step. GraphRAG runs a community detection algorithm called Leiden over the graph. In plain English, it finds the clusters, groups of entities that are far more connected to each other than to anything else. These are communities, natural topics that emerge straight from the structure of your data without you ever defining them. And it does this hierarchically. Big top level communities at level 0, broken into finer and finer sub-communities as you go deeper. Then, the key move, it has the language model write a summary report for every single community at every level. So now, your data has a table of contents it wrote itself, high level themes at the top, fine grained detail at the bottom. And that is what makes global questions finally answerable. Now you've got the graph and the community summaries. Here's how you actually ask it things. GraphRAG has two modes. The first is local search for specific questions about one entity. It finds the entity you asked about, then fans out across its neighbors, its relationships, and the original text around it, and builds a focused answer. That's your precise, zoomed in lookup. The second mode is the one that changes everything global search for whole corpus questions. Instead of grabbing a few chunks, it takes all those community summaries it pre wrote and runs a map reduce. Map. Every community summary independently proposes partial answers to your question, each with a score. Reduce. It ranks all those points by importance and combines the best into one final answer. So when you ask, what are the main themes? It's no longer guessing from a few paragraphs. It's synthesizing across a summary of your entire dataset. Okay, but does it actually win? Microsoft tested GraphRAG head to head against normal vector RAG and had a language model judge which answers were better. Let me be precise, because precision is the whole point of this channel. These are win rates. How often the judge preferred GraphRAG, not accuracy scores. On comprehensiveness, did the answer cover the question fully? GraphRAG won between 72 and 83% of the time. On diversity, did it bring varied perspectives? It won between 62 and 82%. And here's the kicker, it does this efficiently. Answering from the top level community summaries used over 97% fewer tokens than stuffing in the full source text. But I'll be honest with you. Vector RAG still wins on one thing directness. For a quick, narrow, factual lookup, plain RAG is sharper and cheaper. GraphRAG earns its keep on the big, connected questions. So, where does this actually matter? Anywhere the value lives in the connections, not the individual facts. Fraud and financial investigation, where a scheme is invisible in any single transaction, but obvious once you connect the accounts. This is a textbook graph problem. Enterprise knowledge bases, where the answer to a real question is spread across wikis, tickets, and chat logs that no single search ever stitches together. Legal, connecting statutes, contracts, and case law into one traceable chain. Medicine and research, linking patients, studies, and findings across thousands of papers. The pattern is always the same. If your hardest questions need you to traverse relationships, not just look up a fact, that is exactly where GraphRAG pulls ahead. Now, let me be straight with you about the cost, because nothing here is free magic. Building that graph is expensive. Remember, the language model has to read every chunk to extract entities and relationships, and then summarize every community. That's a lot of LLM calls up front before you've asked a single question. And global search isn't one call either. It fans out across many summaries, so it costs more than a simple lookup. Microsoft knows this, which is why they shipped a lighter version called Lazy GraphRAG. It skips the heavy upfront summarization and they report indexing costs of around 0.1% of full GraphRAG, basically the same price as plain vector RAG, while keeping most of the quality. So the honest rule is this: for simple factual lookups, plain RAG is still the right, cheap tool. Reach for GraphRAG when the questions get big and connected, and reach for the lazy variant when budget is tight. And the best part, you can use this today, all of it open source. The reference implementation is Microsoft GraphRAG, free on GitHub under an open license. And it gives you the whole pipeline we just walked through: extract, build, cluster, summarize, query. If you live in a real graph database, Neo4j ships an official GraphRAG package with retrievers that even turn plain English into graph queries for you. If you build with Llama Index, there's the property graph index. And if you're in LangChain, there's a graph transformer that turns raw text into a graph of nodes and relationships out of the box. Pick whichever matches your stack. The point is, the on ramp is shorter than you think. And the moment your data is a graph, your AI stops reading in the dark. So here is the one idea to carry with you. Normal RAG finds paragraphs that look like your question. GraphRAG maps how everything connects and then reasons over that map. That's the leap from searching text to understanding structure. Now, if this rewired how you think about retrieval, I packed everything into a free GraphRAG playbook. The full pipeline on one page: when to use graph versus vector search, and the exact tools to start with today. To get it, just comment the word GraphRAG and I'll send it straight to you. And a quick, honest ask: a lot of you watch every one of these and still haven't subscribed. On YouTube, subscribing is free, and it's the single thing that tells the algorithm to show this to more builders. On Facebook, hit follow, and the supporter membership is what keeps these deep dives coming. And on Instagram, I post the short version of every breakdown. If you want to go deeper, my complete Claude Code guide is linked in the description. Your AI has been reading in the dark. Go give it the map.